We're going to get going. Welcome, everyone, to another installation of our Lunch and Learn series here at the Northeast Biosolids and Residuals Association. Everyone should be muted as you join. I'll ask you to remain on mute until the end of the presentation, when I'm pretty sure I can open it up for questions and answers live. But there is a Q&A function at the bottom of your screen. Feel free to use that. I'll be monitoring it during the presentation, so type in any questions as you think of them. The session is being recorded, and the link to the recording and the slide presentation will be provided to all of the registrants after the webinar, and also on demand for any NEBRA members who are interested and couldn't attend today. So thank you for joining us to learn about an important research project. It's being led by NEBRA member Hazen and Sawyer in conjunction with researchers at Manhattan College, with funding from the Water Research Foundation. I'm so pleased to have the Hazen team here with us today to discuss this project, which will evaluate source-separated organic feedstock pretreatment and management practices. I've said it before, and I have to say it again, the best thing about NEBRA is our members. You all do challenging and interesting work and are always willing to share your knowledge to benefit NEBRA members and the biosolids and residuals community as a whole. So let me introduce some great NEBRA members from Hazen. First, we have Dr. Mohammed Abu Orf, who is the principal investigator for this research project. Mo is recognized around the world as a biosolids processing expert. He's got over 28 years of diverse experience, including consulting engineering, operations and technical services, applied research and development, and academia. He has biosolids expertise, which includes a dozen master plans, various process improvements, evaluating innovative technologies, conceptual design in the area of dewatering, stabilization, and energy recovery. Mo is Hazen's residual group practice leader with 6 patents as the main inventor and more than 130 peer-reviewed conference proceedings under his belt. Next up is Micah Blate, an associate with Hazen in their Philadelphia office. And Micah is a licensed professional engineer with 10 years of experience focused on biosolids and wastewater processes. Micah serves as Hazen's interim Northeast region biosolids lead. He has a BS in civil engineering from the University of South Florida, a master's in environmental engineering from the Johns Hopkins University, and he's currently pursuing a PhD in environmental engineering at Drexel University. He's assisted in utilities throughout the US and Canada with process modeling, process upsets, optimization, planning, feasibility studies, and design of wastewater treatment facilities and solids handling facilities. And finally, I am very pleased to welcome Dr. Daria Durson, a Hazen associate engineer with 15 years of experience on biosolids management and treatment technologies. She is leading Hazen's residuals and biosolids group for the Western region and managing applied research activities for biosolids. She has over 30 publications in peer-reviewed journals and has co-authored several books. So we have some excellent experts here today with us. And for those of you who don't know, NEBRA hosts a Northeast Digestion Roundtable where we help each other learn about anaerobic digestion operations and best practices. We have about 35 operating ADs in this region, but there are numerous manure digesters on farms. And with the trend in diverting organics to landfills, there's a great opportunity for co-digestion of wastewater solids. So welcome, Mo, Mika, and Daria. Thanks for joining us today. You can go ahead and take over the screen sharing. Micah, I am very interested in hearing about this important research. Take it away.
Can you guys hear me?
Yes.
Okay, thank you very much, Janine, for the kind introduction, and thanks to NEBRA for leading the charge on biosolids, beneficial use, educating the public, and doing the excellent work that you and the team are doing. Today, we're really glad to talk about a project, a Water Research Foundation project that I believe started May-June 2020 last year, and really focusing mainly on evaluating source-separated organics, termed SSO feedstock, mainly on pretreatment and management practices. Next, Micah. Okay, so our project team, as Janine mentioned, basically a collaboration between Manhattan College, Professor Rob Sharp, and one of his bright students, Nicole Kaiser, who just, I believe, graduated this summer. There's no need to mention the team because I think we have three of the people that work on the project here speaking to you. We want to acknowledge also Dr. Kelly Landry, who really working on a major task of this project. We also want to acknowledge our utility partners. We had a dozen utility and industry partners, including Veolia, Energia, CCI, Canadian Compost Inc., that basically brings not only North America experience to this project or practice, but also global companies like Veolia, Energia, CCI. They really have a global footprint, so we learned from them as well. Thank you. We also want to acknowledge the Water Research Foundation for basically funding this project. This was a competitive project that started, again, as I mentioned, June last year. We want to really thank Stephanie Faig and as the project manager. We had a lot of fun working with her. We have a project advisory committee, basically leaders in this industry. Dan, he's basically with Associated Engineering. Don Gray, he is with the East Bay Mud. Jamie Ecker, he is basically with Waste Management. Jörg Blischke with Black and Beach, and finally Mark Green. So what are we talking about today? We're going to basically, I'm going to be covering an overview and the project goals, then hand it to both Micah and Daria to take it over from there. Thank you, Micah. All right, so practicing co-digestion. How do we practice co-digestion of source-separated organics? As you can see from this just very simple schematic diagram, you have feedstocks, and we'll talk in a minute about what do we mean by feedstock. That comes in a different forms, etc. It had to be pre-treated, removing contaminants like rocks, plastics, you name it. Anything that is not organics get to be removed, and that is the focus of this applied research project. Once we do that, then another part of the pre-treatment process is making a slurry, because we want to feed that to existing or new anaerobic digestion. We have a slurry tank, and then they're injected along with the solids from the water resource recovery facility to digestion, then dewatering, and then the final beneficial use. So what are the benefits from this practice? With these organics added to the digester, you generate more biogas, and allows utilities like East Bay Mud and others to achieve their energy neutrality goals and become some of them actually become experts exporting energy in form of electricity. What it does, we basically have digestions that do have extra capacity, so it takes advantage of using these existing assets for generating this energy. A major greenhouse gas emission reduction impact is basically diverting these organic materials from landfill, and that is a sustainable environmental practice. For example, Germany, there's nothing goes in land in Germany. Everything has to be recycled or beneficially used. What does that do for North America? Lots of landfills are reaching their capacity. So this is basically when you divert these organic material, valuable resource from landfill, you basically increase the lifespan of existing landfill for that matter. So there are a lot of benefits for practicing co-digestion of source-separated organics. What I'll do is, again, picture says it all. It's everything that is organic, so it's we really had a long discussion at the beginning of this project with the PAC to really get a good definition of a handle. So it's everything pre and post consumer food waste, waste produced from commercial generators, whether it's groceries, spent food, restaurants, food, supermarkets, food processing facilities like dairy waste, animal waste, rendering facilities, any agricultural waste, slaughterhouse, poultry houses, and also residential source-separated organics. I think there are a bunch of cities right now, major cities in North America who practice this. San Francisco is one example. Toronto is another example as well. However, this organic does not exclude, or this part excludes yard waste, wood waste, paper waste. So anything that is not these is considered or source-separated organic material that can be pre-treated. And again, similarly, it's you have characteristics. As you know, like it's really very hard to characterize this. I think there's another project as part of this research to basically characterize, some of the source-separated organics. But as you can see in the diagram, manure, sewage sludge, food waste, as organics basically have little inorganics in it. Then as you go down all the way to residential SSO, that's when you increase in the solids content. You also decrease homogeneity and increasing the contaminations. As you can see, industrial feedstock like sugar waste, breweries, etc., fats and grease, it doesn't have a whole lot of contamination. But as you go all the way down to residential SSO, you still have plenty of contamination. I also want to mention one last thing. This project does not touch fog, fats, and grease. Thank you. So the overall objective of this project really, it's part, as I mentioned, of a research area with the Water Research Foundation. And this whole research area is to provide these water resource recovery facilities with guidance, tools, and what are the best practices out there for the main objective of managing source-separated organics co-digestion program. This specific project is basically focusing on review existing pre-treatment technologies, how to get to the slurry that you feed into the digesters, and the evaluation comes in terms of benefits and challenges. So we're looking to answer three major questions: what technology is currently available, what the facilities consider when they select these technologies. There are vendors that provide a whole package. The system takes it from cradle to grave, and there are others who sell just specific, unique unit operation processes that I believe Daria is going to talk about. Again, ultimately, we look to provide utilities, work subscribers, and the industry with knowledge, again, and confidence in developing these programs and beneficial use of organic waste products. We have 4 tasks in this project. Research project. The first task was to really conduct a global literature review and survey. We went into the U.S. Again, we have a lot of our partners have a global footprint. Again, we looked at a complete, massive, databases and analysis to get that. One thing that I want to say as part of this project, the team would work is looking to develop a database, a Power BI dashboard database that allows the user to really have easy access to the information and not reading, hundreds and hundreds of pages of reports. And this tool will become part of a deliverable of this project. And not only will touch task 1, we'll touch task 2 and task 3. Task 2 is basically focusing on evaluating these existing technologies. And the way we did the evaluation, we developed questionnaires with the project committee and WRRF, and send it to our utility partners, and then get the results back, and that will become a fact sheet. Then we looked into a selected, unique portion of these utility partners to do a detailed case studies where we would want to ask more information, get more quantification information about benefits, challenges, etc. That allows any utility who's looking to do this into their future to really get a fast and understand the challenges they're going after and the benefits. And finally, task 4, we're looking to put together a decision making tool of what you do in order to get from the start of thinking all the way to implementation. Thank you, Micah. And I think Micah is going to take it from here. I'm sorry, Daria is going to take it from here and talk about the task 1. Daria, it's all yours. Thank you.
Hi, everyone. It's a pleasure to have the opportunity to present some of our findings in this exciting research today. I'll be focusing on really our literature review findings today. As Mo mentioned at the very beginning, we have done an extensive survey of existing technologies, what technologies have been used throughout the world pretty much on SSO pretreatment. So really, our approach sort of included 3 main steps. We have identified a lot of work projects, IWA publications, a lot of publications from conferences, a lot of technology scans, technology information sheets. All this information was gathered, important outcomes were listed, and again, there were a couple of key items that we would like to capture or drill out from those publications. So there has been an extensive research that went into that. And at the end, all those results are summarized in sort of dashboard style, so that would give us the ability to sort all this information by geography, by pretreatment size, by technology providers. The entire goal of our literature research was obviously to bring all this information to WRRF subscribers, and also try to identify the pretreatment technologies for our case studies, which we evaluated in task 2. So that was where we started. So just some findings, again, over 100 publications, and as you can see, those publications came all around the world, but really global information was the core, because we knew that the majority of the information on SSO pretreatment was actually originated from Europe and some other countries. So significant attention was paid to capture all this information in there. So you can see from this map that there are a lot of dots around Europe. Still, there are some other locations, especially around Japan. We were able to identify different technologies. And it looks like US is catching up with the literature and then the application of SSO pretreatment as well. Beyond the publications and papers, there have been a lot of web sources also, generally coming from the technology providers. We scanned all those, and over 70 technology providers were really identified that can provide SSO pretreatment. So just a little bit of a background, maybe what to look for and what are the standards for SSO material to be accepted for co-digestion. This is sort of important because when you are designing an SSO pretreatment, it's a little bit unique. It's not like our normal wastewater treatment or biosolid stream, because generally we know where we need to go. We have standards that we need to meet at the end. We have effluent requirements, we have biosolids requirements that we have to meet. However, for SSO, we realize that there are no set standards nationwide per se. We are realizing that each utility that are accepting SSO right now, generating their own standards for their systems. So that was a challenge. So as Mo showed at the very beginning, we have a material that's very diverse. Even defining what goes into SSO was a challenge. And the characteristics could vary significantly. And we also don't have a clear requirements to be accepted for the digestion as well. So with all those sort of moving parts, it's very difficult to decide what needs to go in SSO pretreatment. So that was a challenge. And again, that's sort of that formed the core of our literature survey, probably. So when we did the literature survey, we did look at what are the contaminants, how these could be taken out. We have also looked at some of the operational issues with the co-digestion, digester stability, downstream effects, and sort of how overall impacts. Next slide. One thing that also we realized when we started doing research on this thing is there are really different places and different ways of doing the SSO pretreatment. When we first focused at treatment facilities, water resource recovery facilities, it's possible to conduct the pretreatment on site. But we are also seeing quite a lot these days building centralized SSO pretreatment in different places, and those are generally led by private entities, so that they can take the organics. They generally have good ties with the organic manufacturers or producers, so they take the material, they prepare the material, they do the pretreatment. So after they form it at a central place, then they send the slurry to the treatment facility. So that was another model that we have realized that could be applicable also. We have also realized there are some very little, what really looks like our sort of garbage disposal, decentralized, what it is called as decentralized SSO pretreatment, which we didn't really include in our project. So we, in our project, we really looked at the on-site pretreatment at facilities or centralized pretreatment facilities also. So after looking at all these technologies, we have started grouping things in different ways and different forms. We realized really there are separation processes, there are size reduction processes, and there are homogenization processes that are pretty critical. And there are certain what we call unit operating processes that goes into the main group. For example, sorting and separation, degrading, removing rocks, and sort of screening. Those are all grouped under separation processes. Shredding, grinding, those are mainly used for size reduction in the system. So we group them for under size reduction processes. And the core of all these processes is what we're realizing is generally the pulping, mixing, or blending, what is used mainly for homogenization. So really, those were the three main groups. And again, there are different unit operating processes that could go under that. Sometimes we have seen in the literature that the terminology could be confusing in different regions, different parts of the world. People are calling pretty much same things with different names. So that was another issue we realized. So we had to define those, what those processes are pretty clearly. But at the end, we were trying to generate, okay, step by step, maybe a process flow diagram, what to include in a pretreatment of organics or SSO pretreatment, which was a big struggle, again, without knowing the characteristics in the feedstock and what are the characteristics to be accepted. But overall, what we landed is basically every sort of, you have to have a primary unit operating process. Again, that's generally the blending, pulping, mixing, homogenization that you have to do. Depending on the characteristics of the feedstock, you may need to include and some initial processes beforehand. Sometimes if the organics comes in bags, you need to use trommel screens to open up the bags. If you have a lot of inorganics, you may need to remove them in different processes. Magnetic belts, the separation processes could be included in that. Sometimes even separation, we realize, could be done after even blending, depending on what you would like to separate. At the end, there are some facilities that does apply what we call polishing step, and there are some UOPs, unit operating processes, that could be used for this purpose. Again, a cyclone, mixer, a slurry tank. Again, this whole idea is keeping things in homogenized form and getting the consistency that you would like to have in there. So again, sort of initial and polishing are sort of depends on specific facility that's you need to look at, but you gotta have a primary UOP that should include the homogenization process. We have also developed sort of compatibility chart. If you have all these ingredients or contaminants in your material, what are the processes that you have to add into your SSO pretreatment? So this chart, I know it looks a bit busy, but if you have a metal, what do you need to do to remove it? If you have a lot of plastics in your source, what you have to do it? Which processes could be applicable. So if you see yes, you can incorporate it into your flow chart. If you say no, that's something you shouldn't be adding. If you have a lot of glasses, really shredding, grinding should not be applied before you remove those glasses. So you need to figure out a way of removing those at the beginning, for example. So basically, that's another sort of a tool, sort of a source that we have generated as a result of all this literature survey. Next slide. Another sort of objective of this literature research was identifying the technology providers. Again, we realized there are some technology providers that could provide separate UOPs, separation systems, screening, shredding. They can provide those individually, but there are also some technology providers that provides a complete package per se. There is like a black box, things comes in and out completely as blended. There are different processes in it, but it comes as a package. So that was the main thing we realized while working on this task. We have listed here some of the technology providers we identified. The list is extensive actually, but just those are some examples per se. So hopefully this will be a guidance for the utilities if they are considering SSO pretreatment. But we are seeing quite a lot of interest to more hybrid package processes per se. A lot of companies have started to develop their own equipments for that, specific for organics. So in the earlier days, we were seeing more unit processes brought together by utilities on site. Nowadays, it's more turning into a patented or packaged processes that does it all in one place. Next slide. Just very briefly, impacts of SSO addition on facilities. Really, all these impacts have to be evaluated in 4 main groups. In the design, you have to take into account the impact of SSO addition. In the operations, obviously, that is going to bring a lot of changes. The performance of your system could change, so that's one thing you need to build in. And final product quality also, you have to make sure that you evaluate all those 4 main boxes. There are also some downstream impacts, obviously, that needs to be considered if you are considering SSO addition. And in literature, we have seen a lot of references to those. Odor control could be an issue, the accumulation of inerts, biogas quality, dewatering effects. Again, our project doesn't really aim to look at those, but while we were conducting our research, those were the conclusions we have drawn. The main drivers that's reported in the literature for SSO pretreatment and co-digestion, bringing SSO, some of them were purely regulatory. I mean, like in California now we have a regulations which is going to be effective by January 1st. And by year 2025, we need to divert 75% of the organics from landfills. There are regulations similar to this in Europe, so that you cannot send food waste anymore to landfills, as I think Mo mentioned at the very beginning. So that's one reason. There are other economic benefits in certain places that's reported. Biogas production, increase in biogas has been reported extensively. Resource recovery product lines, incentives on the energy side has been reported. When we list the main barriers, feedstock availability and the quality and consistency of this has been one of the main issues. And economics sometimes could be difficult to balance, economics of scale, if you don't get incentives in different places. And obviously the capacity issues, site limitations were also reported for doing SSO pretreatment and SSO co-digestion. Next slide. At the end, we have also listed the facilities, mainly in the North America, that does SSO pretreatment. And again, that list was taken and to task 2 for us to reach out to them, which Micah is going to talk in detail. That's pretty much it. Thank you. Micah?
Okay, thanks, Daria. Okay, so thank you, Mo and Daria. I'm going to be talking about task 2, which was the evaluation of existing technologies and management strategies. And the approach or methodology that we took for task 2 was to first identify the research interests, and this really built upon what Daria had discussed. What type of things would folks be interested in that are interested in implementing an SSO pretreatment a program? What design considerations were taken? What kind of O&M issues have you seen? How much operating time? Things like that. And I'll provide some example fact sheets here in a few minutes. So we took all that information and research interest areas, and we developed a questionnaire survey that were distributed to our vendor and utility partners. We compiled those results into the fact sheets, which I will share in a few minutes here. And then similar to some of the other tasks like Terry mentioned, this will get placed into a user-friendly version, Power BI dashboard. So users will be able to select different interests, geographies, types of equipment, types of SSO, and then so you can kind of filter the results and see exactly what you want to. So as we started thinking about this and discussing with our partners and internally, we realized something sort of unique. There was 4 unique, what I'll call buckets of SSO pretreatment or receiving. So the 4 types are that the facility performs all of the SSO pretreatment on site. So the facility or utility owns and operates all of the pretreatment on site. The next is that the WRRF performs some treatment to pre-treated SSO waste. So most of the treatment is off-site by others, and then there's a small polishing step at the facility. Then there's the third bucket is where the facility receives pre-treated SSO waste. So these are facilities that receive a pre-treated waste from a vendor like Waste Management or Divert. And then there are the more unique and I guess what I'll call more uncommon is where it's a standalone pretreatment and digestion facility. So there are these are our utility and vendor partners, and I know there's a few of the partners here on the call today. So thank you to the Greater Lawrence Sanitary District and DEP. I saw a couple of you folks on the call, so thanks for your assistance in this project. But like I mentioned, we had distributed these questionnaires to all of our partners, and we received questionnaires back from 18. We received 18 questionnaires back. Like Mo and Daria had mentioned, we really wanted to procure international experience since most of the technologies were established overseas, whether it be Europe or Asia. So for example, Veolia and Energia and CCI had provided fact sheets relative to their facilities and experience overseas, as well as some experience here in North America. So in total, we had received 18 fact sheets. And this graphic shows the different facilities that we received fact sheets from and the specific bucket that it fell into. And I don't want to bore everyone with too much detail here. So I've circled 4 fact sheets that I wanted to share today to give an example of what the final product may look like. So within the WRRF performs all SSO pretreatment on site, I'll show the example fact sheet from Hermitage, which is in Pennsylvania. And the WRRF performs some treatment to pre-treated SSO waste. That's the Central Marin facility in California. The WRRF receives pre-treated SSO waste bucket. That's the Rahway Valley facility in central New Jersey. And the standalone pretreatment and digestion facility is the Dufferin Organics Processing Facility in Toronto. And you also see the other thing that we wanted to capture was what type of equipment providers or technology providers are actually on site. So you know, we wanted to sort of capture that. Energia, Waste Management, West Salem Machine, and Hermitage has a few. So I'll discuss that in the next couple slides. This is the sort of the generic fact sheet that we have. On the left is the background of the facility. Down on the bottom, we're showing equipment, insight, motivation, design, and O&M lessons learned. And then in this sort of central top right part of the fact sheet, we're showing a process flow of the equipment on site. So for example, this is the Hermitage facility. This is located about an hour north of Pittsburgh in Western Pennsylvania. And this is a 8 MGD WRRF, excuse me. And this facility has been in operation since 2016. And the driver for this facility was they are a WAS only facility. So they wanted to find a way to make their a more digestible product, since WAS is not that digestible. And they're also striving towards energy neutrality since they have a CHP on site, excuse me. And originally when this went into operation in 2015, they only had one depackager on site. They started with the RMI perforator. And what that could do was take material in like liquid containers, and it could poke holes in it, and then it would collect that liquid. So they found that to be very successful in terms of depackaging and also increasing the biogas, generating revenue from the tipping fees. So then they looked at, hey, this is great. You know, what can we do next? So the second depackaging system that they got was the Scott turbo separator. And that allowed them to depackage solid organics, so like expired vegetables, stuff like that. And then the final depackager that they got was the E-Cruiser 1000 from Veolia. And that's more of an all-inclusive type system that can unpack, grind, and separate. And the equipment is completely maintained on site. I'm sure a lot of folks may have seen Tom Darby, the plant manager, present at various conferences, but a really successful, interesting, and unique program that they've implemented for the last 6 years. The next facility, this is the Central Marin facility located in California. It's a 10 MGD facility. And I guess what's unique about this facility is that you can kind of see the bluish color outline, and that's the equipment that is off-site. They have a large off-site location in which they receive commercial food waste, excuse me. So off-site, they first have a West Salem machine shredder that looks kind of like that graphic there, and that breaks up the material. Then it goes through a belt conveyor magnet system, so remove the metal magnetic material, excuse me. And then it goes through a hammer shredder, and finally a grinder, and then it's hauled to the WRRF and gets conveyed and dumped into a receiving tank, and some more polishing is done on site with a rock trap, a grinder, and then it's kind of gone through a paddle finisher before it's sent to a anaerobic digester. So like I said, this one's been in operation many years, or not many, 7 to 8 years. So really interesting facility as well. So this Rahway Valley Sewerage Authority, it's located in central New Jersey. It's a pretty large plant, and the driver for them was they wanted to find a way to increase the gas production at the plant. They had a ton of excess capacity in their digesters, and then they were anticipating a food waste recycling legislation in New Jersey when they had implemented this program back in 2018. And this facility actually receives completely treated SSO from Waste Management through Waste Management's core process, which is a proprietary process. So, that's sort of like the black box. We don't know what goes on there, but the material that's received by Rahway Valley is completely treated. They receive it in what is formerly a gravity thickener, and then they pump it into their digesters. Some of the things that they found was the materials of construction are important. SSO has a low pH, and then stuff like clogging and means to wash out any of the piping is very paramount to a successful program. And then we have the final fact sheet that I'll be sharing today. which is a standalone SSO processing and digestion facility. This is the Dufferin Organic Processing Facility located in Toronto, Canada. And this has been in operation a couple of years, also 2018. So they have a bag opener. They receive residential food waste that goes through a bag opener. Then it goes through the Energia WRRFs package system that Daria had kind of talked about a little bit. And then they have the Energia dual cyclone. It's shown as two separate cyclones here, but it's a combined unit. And then it goes into standalone digestion. So this is a really interesting facility. Not many like it, but definitely interesting experience to be included as folks look into this type of process. So task 3, we're sort of in the task 3 process right now. And what I didn't mention in task 2 is that another thing we wanted to do in task 2 was identify 6 or 7 of these facilities that we wanted to include for more detailed case studies. And the approach that we took for task 3 was similar to task 2 in that we developed a questionnaire, but we really honed in on some more details and things that we learned while we went through the fact sheets. Maintenance requirements, impacts to downstream equipment, quantities, water, chemical requirements and costs. And similar to the previous 2 tasks, this will be compiled in a Power BI dashboard. And I would like to share the case studies that were selected. So I'll start on the right side. In the standalone category, we have, in the standalone pretreatment and digestion facility, we have 2 Toronto facilities, Dufferin, which I talked about in a few slides back, and then also the Disco Road facility. So what's interesting about those 2 facilities is that they'll be receiving similar waste because it's the same area, same feedstock, but they have different technology providers and different processing steps. So we'll be able to get some neat, contrast between the 2. From the WRRF perform some treatment, the Central Marin facility that I discussed, and also the joint water pollution control plant in Southern California, LA. And then the 3 where the facilities perform the SSO on site. Hermitage that I discussed, East Bay Mud, and international experience from Hungary. So this is just a quick glimpse of the questionnaire and kind of what we came up with. Like I mentioned, we wanted to really hone in more detail. So this is a snip of a mass balance that we're looking to create as part of this. So we're looking for process inputs, outputs, like I said, chemical, water requirements, all of those sort of items. And then any operational and financial information and downstream process impacts. So like I said, we've released these questionnaires with the 7 utilities. We've held brief calls with each to kind of talk through this. So in the next couple of weeks, we should be wrapping up this task. And the final task is where we will develop this pretreatment decision and analysis tool, or PAD. And this is still a work in progress, but the idea here is that we'll have a flow chart that's sort of like a logic where, a utility or a party interested in SSO pretreatment can walk down this flow logic with a yes or no answer. And as you walk through, it'll say, for example, is there a waste management core nearby? And then if the answer is yes, maybe it's okay, maybe you want to just receive pretreated SSO. If the answer is no, then it's, perhaps you would like, perhaps you need to do the processing on site. Have you characterized the feedstock? Yes or no? Yes, and we know it's X, Y, or Z. So then you know which type of equipment to implement on site. So this is a work in progress, but this is a very exciting part of the project because it's the main goal, you know, to help utilities looking to implement such a program. The report will be published in the summer of 2022, available to all WRRF subscribers along with the Power BI dashboards. And with that, we just want to thank you for joining us today. I've put all of our email addresses on here. If you have any questions, we'd be happy to field any questions with the remaining time we have, or feel free to email us.
Yes, thanks, Micah. We do have a question. Do the WRRF facilities that you studied have specifications for physical contaminant limits? I think you alluded to that they're all different, but what are you finding?
Yes, Rahway Valley, I know for Rahway Valley, they shared their specification. They have a very stringent spec on the type, the material that they receive. So they clearly specify the TS%, the nutrients, the COD content. And I think Derry, you had shared a slide on that on LA.
Yeah, I think that's slide number 13, if you want to sort of show that. That was an example from LA, actually. So LA County sanitation districts, you can see on the right side, there are limitations identified for pH, TSVS, COD, BOD, all these requirements are listed. So yes, majority of the facilities come up with their own criteria.
Another question, for the WRRFs performing all of the SSO pretreatment, did you collect data on the level of contamination they're seeing by weight and or volume, and will that be included in your report? Excellent question there.
Let me answer that. I think this is not the part of this project. There's actually another parallel project, I believe, that is going through, that is looking specifically to take samples from different SSO pretreatment facilities nationally and do analysis and quantifications on the slurry as it goes into the digestion for co-digestion. And I think, again, as Micah mentioned, one of the uniqueness of the two facilities that run are basically implemented by the City of Toronto, having two different pretreatment technologies on the same waste, I think that results are going to be basically very beneficial in terms of this. I also want to say that our project manager, Stephanie Fay from WRRF, is looking to have a workshop where we're going to present in the, I think, the 2022 Residuals and Biosolids Conference, where we present both of these. So you'll get to see both projects, the projects that look at characterizations of the waste, and this project that looking at the evaluation of these technologies. So hopefully you can be in that conference and participate. But our task was not to go into quantification.
Fair enough. Of course, we had to have a PFAS question. Has there been any PFAS analysis on the SSO streams that you found during your research or anywhere else? I know we have a little experiment going on in Nantucket that I'm hoping to do a webinar on coming up. But
no, we have not. That was not of our any questions. Although it's a very good question. I think if you look at the literature, some of the food, the packaging, as we know, PFAS basically in every product that we practice in packaging, etc. So we expect to have some input to the utility from the SSO into the PFAS. So I think if the utility is interested and if that's a concern for them, part of that, I think the slide is excellent, is to have it in the specifications, and they specify the amount of PFAS within that slurry and require it to be tested.
yes, good suggestion. let's see if we have another question. Sure. Is the evaluation of waste in the other project mentioned by Mo to cover the feedstocks going in or the biosolids coming out?
Just the biosolids go, I'm sorry, the feedstock going on. I don't think the biosolids going out. No.
Okay. All right, thanks. And then I just had a question, maybe a big picture question, if there's no others coming from the audience here. But it seemed like all of the standalone facilities that you found were in Europe or not in the United States. And I'm just curious about the differences. Were there more regulatory drivers? What's going on? Why are we behind the 8 ball here in the US?
Well, let me take a stab at Daria. I see you mind. Maybe you have something that
Yeah,
I think Europe, just 1 minute. Europe basically, as I mentioned, stopped landfilling a long time ago of organic materials before us, and that led to them being ahead of us in this country in this. And I think if you look at the city of Toronto, as an example, when they implemented their first facility, Dufferin, if you look at the beneficial, the economic analysis of this, they were not, the amount of biogas generated did not outweigh the cost, but they still implemented the project because of the, again, diversion of organic greenhouse gas effect. We want to be more sustainable to the environment. So there were other issues, and again, maybe we're still behind. Daria, you want to add something else?
Yeah, it's just in US, we generally don't have a lot of land restrictions as opposed to in Europe. The countries are pretty small and there are not many places for landfilling. So landfilling is very, very strict. So they are trying to minimize the amount that they are sending it to the landfills because they don't have any more space. Same thing that we saw in Japan. They don't have the land to have a big landfills like we do in here. So that's sort of where it started, I think, several decades ago. But nowadays, it's mainly related with greenhouse gas emissions. A lot of European countries are considering, and they are ahead of us because they have been looking at greenhouse gas emissions before we have started looking at here. And again, that's the same driver. We are seeing it now in California. The main driver of those diversion goals that we have is because of the greenhouse gas emissions.
Thank you very much for that perspective. I don't see any other questions, so thank you guys so much. Thanks, Mo, Micah, Daria, for presenting your research today. Very interesting, and I hope to hear the final results at some point as well. Thanks to everyone. Yeah, thanks, Mo. Thanks to everyone who joined us today. We have these sessions lined up through October. If you have anything you'd like to hear about, let me know, and I'm happy to make that happen.
Have a great Friday, everybody, on the weekend.
You too. Thanks, Hazen. Thanks, Team Hazen. See you guys.